Welcome to today's lesson. We're going to explore the concept of pressure, a physical quantity that explains why sharp objects hurt more, why nails can pierce wood, and how force becomes more effective when applied on smaller areas. Pressure is a fundamental concept in physics that explains how force distributed over an area affects the intensity of its impact. It plays a crucial role in everyday life and engineering applications. The concept is based on the observation that when the same force is applied over a smaller area, the effect becomes more pronounced. For example, pressing a sharp object against a surface causes more damage than pressing a blunt object with the same force. This principle is essential in understanding why tools like knives, nails, and pins are designed with sharp ends. Pressure is mathematically defined as the force acting normally per unit area on a surface. The formula for pressure is pressure equals force divided by area, and its SI unit is Pascal, Pa, equivalent to 1 Newton per square meter, N per square meter. This definition emphasizes that pressure depends on two factors: the magnitude of the force and the size of the area over which the force is applied. A smaller area results in higher pressure, while a larger area reduces pressure. This principle is widely applied in various fields, including construction, medicine, and everyday tasks, making it an essential concept for students and professionals alike. One of the simplest demonstrations of pressure involves pressing a pencil between your palms. When the pencil's sharp tip is pressed against the palm, it causes discomfort or pain because the force applied is concentrated on a very small area, resulting in high pressure. Conversely, when the blunt end of the pencil is pressed against the palm, the discomfort is significantly less because the force is distributed over a larger area, reducing the pressure. This example illustrates the direct relationship between area and pressure. Smaller area leads to higher pressure, while larger area leads to lower pressure. This principle explains why sharp objects like needles and pins penetrate surfaces easily, whereas blunt objects require much more force to achieve the same effect. Understanding this concept helps in designing tools and equipment that maximize efficiency by optimizing the area of contact. A drawing pin or thumbtack provides another clear example of how pressure works. When you press a drawing pin with a sharp tip into a wooden board, it penetrates easily because the applied force is concentrated on the tiny area of the sharp tip, creating high pressure. In contrast, if the pin had a blunt tip, it would be extremely difficult to push into the board because the force would be spread over a larger area, resulting in lower pressure. This example demonstrates why sharpness is a critical design feature for tools intended to pierce or cut materials. It also highlights the practical application of pressure in everyday life, from fastening papers to woodworking. The concept reinforces the idea that reducing the area of contact increases the effectiveness of the applied force. Relation between area and pressure. The relationship between area and pressure is inversely proportional. As the area decreases, pressure increases, and as the area increases, pressure decreases. This principle is fundamental in understanding why certain objects are designed with specific shapes and sizes. For instance, sharp tools like knives and needles have very small contact areas to maximize pressure and make cutting or piercing easier. Conversely, objects like snowshoes are designed with large surface areas to minimize pressure and prevent sinking into snow. This concept is widely applied in engineering, medicine, and sports equipment design. By manipulating the area of contact, we can control the pressure exerted on a surface, making tasks more efficient and reducing the risk of damage or injury. Understanding this relationship is essential for problem solving in physics and practical applications in daily life. Real-life applications of pressure. Pressure plays a significant role in numerous real-life applications. Knives and blades are sharpened to reduce the area of contact, thereby increasing pressure and making cutting easier. Nails and screws have pointed ends to concentrate force on a small area, allowing them to penetrate wood or other materials effortlessly. High-heeled shoes exert more pressure on the floor compared to flat shoes because the heel has a smaller area of contact, which can even cause dents on soft surfaces. Similarly, in medical applications, needles are designed with sharp tips to minimize pain and allow easy penetration of the skin. These examples demonstrate how understanding and applying the concept of pressure can improve efficiency and functionality in various tools and devices. The principle of pressure is not limited to physics but extends to practical design and innovation in everyday life. Summary: pressure is defined as the force acting per unit area on a surface, and its SI unit is Pascal, Pa. The concept is crucial in understanding why sharp objects are more effective than blunt ones and why certain designs optimize performance by manipulating the area of contact. Key takeaways include: pressure increases when the area decreases, and pressure decreases when the area increases. This principle is applied in various real-life scenarios, from cutting tools to footwear design. By mastering this concept, students can better understand physical phenomena and appreciate the practical applications of physics in everyday life. Thanks for watching. Don't forget to like and subscribe for more videos.